Neither of us has ever come close to playing football professionally. Otherwise, we probably wouldn't be studying computer science at ETH or participating in hackathons like the one organized by SkillCorner together with Zurich Sports Analytics Club. But fortunately, we did. And today we're excited to present you our winning project. My name is Ryan Fuchs, and together with Gamal Hassan and Haaroon Hussain, we had the opportunity to transform tracking data from the Switzerland versus Germany game into actionable football insights. Coming from amateur football backgrounds, we started with a simple idea, something we heard countless times throughout our playing careers. Create chaos to create chances. We wanted to test whether that phrase actually could be measured in a game like the one provided. Using tracking data, we developed several indicators that we believe capture moments of chaos on the pitch. But we quickly ran into the problem. How do you validate those indicators? How do you even visualize chaos in football? After digging deeper, we realized we weren't the only one struggling with this challenge. So we built Phasing, a tool designed to detect, analyze, and visualize dynamic game sequences using tracking data, turning abstract movement patterns into comprehensible tactical insights. Phasing and its main feature MatchLab helps you define and visualize your indicators for football analysis based on tracking and event data. But let's have a closer look at our UI. At the top, we have the match timeline with all key events mapped out. It includes a time indicator and speed regulator for control playback. Next, our main view component visualizes the tracking data on an interactive pitch, where you can focus on players or tactical concepts. To inspect your indicators, we created the phase breakdown and the frame indicator, giving you a clear sense of what's happening in the current frame. And if needed, you can always sync with the broadcast to get more insights on the current situation.
At the core of our system is a beautifully simple idea. An indicator is just a mathematical function taking a frame as an input and outputting a normalized score in the range between 0 and 1. That's it. This simple architectural decision is exactly what makes it powerful. Because indicators are just functions, they compose, they aggregate, and they filter. An indicator function can be as simple as a single arithmetic computation, or as sophisticated as a whole deep learning algorithm. We, for example, use the shape graph library under the hood for many of our pilot indicators. What we've built as part of Phasing is a Python framework that puts this elegant idea into the hands of data analysts. By speaking Python, we plug straight into the world's richest data analysis ecosystem. Your job as an analyst? Write the function. Simply write the indicator function and plug it into our framework and watch the magic happen. Our elegant approach allows you to rapidly prototype indicators, test their effectiveness against real-world data, and iteratively improve on them. That's how we developed our pilot indicators. And to make this even more powerful, our library is specifically optimized for AI coding assistance, ensuring the best possible performance, cleaner code generation, and more reliable output when used inside AI and agent-driven workflows. But more on this later.
Ryan just showed you what MatchLab can do, but let me take you behind the scenes of why we actually built it. He also mentioned that we had the same coaching advice over and over again. Create chaos to create chances. So for this hackathon, we wanted to see if we could actually quantify that chaos using code. But we immediately hit a massive bottleneck. We were working with raw 10 Hz tracking data. We use those data to write our metrics, indicators, and algorithm to run it. And it finally spits out some high chaos score at minute 42 on the terminal. It's cool, but can you really trust it? Did you actually find a brilliant tactical breakdown, or was the math just simply flawed? To figure that out using the old way, you need to manually pull up the broadcast video, scroll through, and find the exact seconds you're looking for. And then try to visually guess if what you're seeing matches with your algorithm. It is a really slow process. Trying to validate complex spatial concepts by staring at raw data in the terminal is basically flying blind. We realized we could not truly test our hunches and theories until we had a tool that synced our math directly with reality on the pitch. We also had issues with was never getting the full picture to assess the situation. You never know where everyone is on the pitch without having to piece together different broadcast angles in your head. Hence, we built the interactive 2D pitch while still having the broadcast on the same page to still get actual full picture. And solving all of that is exactly why we built phasing. But we had one more massive problem to overcome. Goals do not just happen out of thin air. They are the result of a chain reaction of various previous events. Comparing these different indicators and tracking how those indicators interact in the build-up to a goal was incredibly difficult. So that's why we built some pilot indicators. So let's look into some of those pilot indicators. As Gamal mentioned that our framework treats every indicator as a simple math function, but the logic running inside those functions can range from basic physics to complex spatial algorithms. To test the system, we built a few pilot indicators. For example, ball acceleration. This indicator just looks at the height, speed, and directional change of the ball to measure its current energy. If a player takes a massive shot on the target, this value is going to spike. But it's a very basic metric, but it is incredibly effective at showcasing moments of sudden intensity on the pitch. Some other indicators are much more complex, like the indicator for player clusters. This indicator detects the exact moments when the distance between players gets smaller and the proximity to each other get higher, for example during a dense high pressure battle for the ball. We can see this in the game as well, where Florian Wirtz, before he scored the second goal, most of the players were inside the penalty box. And this allowed him to get a nice attempt on the goal and to actually score one. And we can go even one step further to simply combine indicators using phasing. For example here, the indicator for line-to-line acceleration, which uses two simple indicators, one from the defensive line acceleration and the other from the offensive line acceleration, and takes the difference of it to create the line-to-line acceleration. This is the true power of our system. You can quickly iterate on top of previous indicators you built using phasing.
In today's age of LLMs and AI agents, we want to take this even further. As you have seen, our framework is incredibly straightforward, perfect for coding agents. Imagine you have a completely new idea for an indicator, but you're not sure how to implement it, or simply don't have the time needed to implement your intuition by hand. Instead of spending hours figuring out the implementation details, we want you to simply describe your concept to our integrated AI agent in plain English. And it generates a working indicator function for you, ready to be run in MATLAB. No boilerplate, no setup, no code dependency hell, just your idea brought to life in seconds. In a world where AI can translate intuition into code, we want analysts to stay focused on the actual problem, not the implementation. This is exactly where the field is heading. Natural language querying and AI-generated insights are becoming standard in analytics tools. Analysts are increasingly judged on how well they direct and validate AI systems rather than on writing code themselves. Our vision for phasing goes even further. We want it to be more than just a framework for analysts. We believe that analytical insights can only emerge through collaboration. Whether you're part of a team, a community, or a hobbyist, we want to build a platform where you can share your work so that collaborators can discover, download, and test your indicator functions. That's why we're building the Indicator Hub. The main feature is straightforward. Discover indicator functions created by your peers and try them out directly inside phasing. By integrating the hub directly into our platform, you can try out various indicator functions directly on MATLAB before ever having to touch a single line of code yourself. Just click on Try in MATLAB and see how the indicator function performs with your data, staying true to our principle of rapid prototyping. Imagine you're an analyst trying to measure defensive compactness. Instead of starting from scratch, you simply search the Indicator Hub, find an indicator someone else had already built, and have it running on your data in seconds. That's the kind of workflow we want to enable. And once you find something you like, you can install it as is, or install it and expand it with your own ideas. Remember, indicator functions are just lines of Python code. Nothing stops you from installing an indicator function and tuning its internal parameters or combining it with a new idea of yours. We believe that this kind of collaboration, where peers share their ideas as functions, unlocks a powerful new way to perform football analytics. But why stop here? Collaboration doesn't stop at sharing. Ideas evolve, so we're also introducing a versioning system for indicator functions. Think about a professional football club setting where analysts build entire workflows and pipelines on top of indicator functions. If the underlying indicator changes, those pipelines may break. Versioning solves exactly that. Creators can iterate and improve their indicators over time while existing integrations remain stable. The same discipline that makes open source software reliable is now applied to football analytics. Taken together, our goal is not just to provide a tool for data analysis, but to build an entire ecosystem for collaborative football analytics. Think of it as the GitHub for football analysts. That's what phasing is. As the hub grows, it becomes a living knowledge base for the sport, where the best analytical ideas surface, get refined by the community, and compound over time.
So, we set out to see if chaos really creates chances. And while we may not have fully answered that question, we built something valuable along the way. A fully working framework for testing your own ideas, indicators, and concepts, as well as a community-driven ecosystem for sharing and improving indicators. We'd like to thank SkillCorner for giving us the opportunity to present our solution. And if you have any questions, feedback, ideas, or suggestions, please feel free to connect with us on LinkedIn. We'd love to hear your thoughts and continue the conversation. From chaos to clarity, less guesswork, more validation. Welcome to Phasing.